we can have like more face-to-face talking. Use limit comparison test to determine if the convergence or diverge of this one. Okay, so I'm going to ask another student here, and let's tell me if it's diverge or converge. Jasper, could you please tell me if the number 8 diverge or converge?
It converges.
Why does this one converge?
You can compare it with 1 over 6 to the n, which is a geometric series.
1 over 6 to the power n. Yeah, it's a geometric series, right? Okay. All right, so this one converge because the geometric series is 1 over 6. Very good, perfect. And this one, let me see. Question 9, the question have several parts, must complete several parts. And this one diverge or converge. Oh, you can continue, can click to begin. All right, so we just, wait. I would just ask you, ask the student help me to finish this. We don't have to look through all of this because we've done so many tests. Okay, so I'm gonna call student here. Joshua, could you please tell me number 9 if it converge or diverge?
It converges.
Why does it converges?
You can compare it to 1 over, is that 5?
Yeah, it's 5. That's 5.
Okay.
I can compare with what? Wait.
You can compare it to 1 over 5 to the n, which is geometric.
Oh, is a geometric series? Yes, you can compare the 1 over 5 to power n, and you get the number is going to be 6. 6 is still L. L is as long as L is a constant number, positive, finite, that'll be okay. Okay. The comparison test, you have to just make sure they don't go to infinity if you compare 2 series. Ratio test, you compare the same series, so you have to make sure the next one over the current one is less than 1. Okay, that's the difference between comparison test and ratio test. So now this one, does this one converge or diverge? Since we're going to do another round. Thea, could you please tell me if this one converge or diverge? Number 10. Yeah, this one diverge because you can compare this one with 1 over n. The n square root and n square actually cancel out. You have 1 over n. 1 over n diverge because the p series p equals 1. I think everyone is doing very good job on the comparison test. Alright, so use a limit comparison test to determine if it converge or diverge. We're going to do next round. I'm going to call student here again. Matthew, could you please tell me if this one diverge or converge?
That one will converge because you can compare it to 4 to the n over 7 to the n.
Okay, the 4 to n to 7 to n is what series?
Is that geometric?
Yeah, geometric series. 4 over 7 is geometric series, and it's 4 over 7. The ratio is less than 1, so it converge. Alright, so next one is a limit comparison test. I'm going to call the next you. Lacey, could you please tell me if this one converge or diverge? Number 12.
I think it converges.
It converges. Why does it converge?
Because if we compare that to, if we divide that by n plus 1, n plus 3 over n plus 1 squared minus 2n is 1.
Alright, any other student? I think you did it to maybe a little bit too complicated because it should be very simple compared with some simple series. Think about the degree, the difference of the degree. What's the difference between the degree?
1 over
1 over n what? This is first power, this is cube power, so it's square, right?
Yeah.
Okay, so basically for this kind of this polynomial, you just look at the highest power, the difference is 1 over n squared. So I'm going to compare with this one because I can easily tell that the series of 1 over n squared, this one converge because it's a p series, p equals 2 bigger than 1. That makes sense, right? But if I compare with this one, what happened? I will have the same power n cubed on the top and n squared, 2n squared on the top and n cubed minus 2n plus 9. We know this will equals 1 because this kind of all of these other things will be 0. If you divide everything, you can use L'Hopital rule, or you can divide everything by n cubed, divided by n cubed, divided by n cubed, divided by everything by n cubed. So all of this will goes to 0, also goes to 0. Just have the 1 over 1 is 1. And since this one will goes to 1, which is a finite positive number, so both of them converge or diverge. Since the bottom 1 over n squared converge, so this series will converge as well. Does that make sense, Lacey?
Yeah, it does.
Okay, very good. Okay, number 13. I will ask a student to help me with this one. Travis, could you please tell me if this one converge or diverge?
We don't converge.
Why does it converge?
Can you compare it to 1 over n to the 9?
Yeah, you can compare the one with 1 over n to the power 9. The reason you can compare those two because you can have this is 1 over n to the power 9 plus 5 to n to the power 8. So if you compare it with 1 over n to the power 9, you're going to have n to the power 9 over n to the power 9 plus 5 n to the power 8. This actually equals 1. This one does not change anything because the highest power is 1. As 9, you check the coefficient is 1. So less than what is a positive constant. So both of them diverge or converge at the same time. Or you can directly use comparison test. You know that n to the power 9 plus 5n power 8, this is strictly less than 1 over n to the power 9. Because this is bigger than this, is the whole thing is less than this one. This one converge. Direct comparison is okay too. So this one converge because this is a p series n equals 9. Okay. So next one, comparison test. This one, I'm going to ask a student here again. Nicholas, could you please tell me if this one converge or diverge?
I forgot what you compared this one to. So you can just go n to the k, right?
Okay. You compare this. Wait, my bad. So when you compare this one, what you have is the top is, I think the top is 1 over k. Is it n to k plus 1? Sorry, is the power n minus 1 or the minus 1 is this whole thing? It's like this, or it's on the power? Can anyone tell me? Is it a power k minus 1 or is it the bottom k minus 1? I think it's on the power, right? Okay. So if it is on the power, then I just need to compare the difference of the degree. This is n k minus 1 power. This is the k power. So they have degree. They have one of n like first degree difference. So if I divide it with that, then they're going to have the same power again. So it's n to the power k, n to the power k plus 3. since this one equals 1, since this one diverge, so this one will diverge as well. Thank you very much. Okay. Next one, number 15. I'm gonna ask a student here again. Jasper, could you please tell me this one?
I'm not entirely sure what to compare it to.
Okay, so I'm gonna call another student. Does anyone have any idea which one do I compare it with? Can anyone tell me? What do you think I compared it with? 1 over n. Very good. So 1 over n compared with 1 over n. And then what do you get for here? Since 1 over n is, I compare this one, limit n goes to infinity. If I compare these two, okay, so we know that n goes to infinity, 1 over n goes to 0. So it's sine 0 is 0. 1 over n is 0 over 0. So it's 0 over 0 form. I can use L'Hopital's rule. So n goes to infinity. For this one, I'm going to take the derivative of that. So it's cosine 1 over n times 1 over n prime. Make sense, everyone? So then, the bottom, I take the derivative, so it's 1 over n prime as well. Because that's a L'Hopital's rule. These two canceled out. But now, n goes to infinity, this one goes to cosine 0. And this is 1. So sine 1 over n over 1 over n, both of them together, this one goes to, it's pretty much like a sine x over x. And when x goes to 0, it's the same idea as this one, okay? 1 over n or 1 over m, actually this both of 1 over n goes to 0. So it's the same idea as sine x over x. When x goes to 0, it equals 1. If you remember that, okay? So, just give me 1 second. I think this always asks me to do that. Right, so now I got this is cosine 0 equals 1. And since 1 over n, the series 1 over n, since series 1 over n diverge, because this is p series p equals 1, so the whole series will diverge. Okay? Number 16. So I will ask a student to help me with this one. This is the alternating series. And this one diverge or converge. I'm going to call a student here again. Luke, could you please tell me if this one converge or diverge?
It's gonna converge.
It's a converge. Why does this one converge?
I can't quite remember what.
Alternating series, what do we need to do? Alternating series, first is a limit. N goes to infinity, an equals 0. That's the first requirement. For alternating series, negative to the power n, a to the power n, right? Okay, for alternating series, this is the first requirement. Second requirement, an plus 1 and an less than, bigger than, or equal. Can you tell me, Luke? I give you two options, actually not equal, right? Less than or bigger than?
That needs to be less than.
Less than an, perfect. So as long as I can prove these two conditions, then it is an alternating series, then it converges. So now, first limit, n goes to infinity, 1 over n plus 5, this equals 0. First check. Second one, an plus 1 is going to be 1 over n plus 6. An is 1 over n plus 5. Since the denominator is bigger, that's the whole thing is smaller. So the second one will also check. An plus 1 is less than an. That's true. Since I have two conditions are met, then this dot series converge. Does that help, Luke?
Yep, it does. Thanks.
Okay, great. Next one, this is also a alternating series. I think it does not ask you for the series. It asks you for the sequence. Just one term here. N goes to infinity. This is pretty obvious. This is 0, right? It doesn't ask you the whole series. It only asks you the term. One single term is perfect. It's easy, but the whole thing converges as well, because it's e to power n, and it is alternating series. And e to power n, if you add absolute value, you converge, absolutely converge. Not mentioning the self converge as well. So you can compare to e to power n plus 1. 1 over e to power n plus 1 is less than 1 over e to power n. You can use alternating series as well. Both n goes to infinity equals 0, n plus 1, an plus 1 less than an. That's true. Alright, so this one, I will call another student here. Call student here. Oh, Joshua, could you please tell me if this one diverge or converge?
It diverges.
Why does this one diverge?
Well, you get infinity over infinity form and plug infinity, so you use L'Hopital's and you get 4/3, which is greater than 1.
Okay, so the problem, do we compare with the greater than 1 or less than 1 something? Okay, so now what if I change this? What if I change this? If I change this into 3n plus 1, I change this, 4n minus 1. Does this one converge or diverge? Joshua?
Converge.
Why do you think this one converge?
Equals.
Okay, so 3/4 is what? Is the nth term, right? We're not doing any of ratio test, geometric series. We're not doing any ratio test. We are talking. When you do 3/4, you are talking about the nth term, right?
Yeah. So it's not 0. So that means it diverge.
It diverge. Okay, perfect. It diverge. Since we're not using any of the ratio test, comparison test, you are talking about the nth term. Well, you think, oh, what if I use the nth term? If you use the nth term, you're going to get a 1. Because 3n plus 1 over 4n minus 1, if you divide it by, well, you can do that, plus 1, minus 1. If you divide it by another 3n plus 1 over 4n minus 1, if you divide it, it's just 1. It's inconclusive. You cannot make a decision because the next term and the previous, this is a 3 over 4. This is 3 over 4. You compare them, it's still 1. You cannot make a decision for the ratio test. Okay, so that's why you cannot. But it diverges because nth term does not equal 0. Okay, so this one diverges because the nth term equals 4 over 3 and it's not 0. We don't compare it with the 1 because the nth term. Alright, so this one, number 19, I'm going to call student here. Zijian, could you please tell me if this one converge or diverge? Zijian. Does this one converge or diverge? It's alternating series. You have to press the button when you answer a question. Okay, so can anyone else tell me if it converge or diverge? Number 19.
It converges.
It converges because
The limit is 0 and it is decreasing.
yeah, very good. Thank you very much. I didn't pay attention who asked the question. Thank you. Limit n goes to infinity, an equals 0. First one, that's obvious. Second thing, because it decreasing, 1 over 2n plus 1 plus 4 is less than 1 over 2n plus 4. That's obvious. Because the denominator is bigger, the whole thing, the whole fraction is smaller. Okay, so alternating series converge. Number 20. So I will ask a student to help me with this one. Thea, could you please tell me with this one, if this one converge or diverge? Why does it diverge? Because the limit equals 1 and the what? It's not equal to 0. Perfect. That's very good. Because we're using nth term test, if I use nth term test, this is probably just if I use the nth term test, limit n goes to infinity, an will equals n3 nq plus 6 limit. The 6 don't change anything. We just compare the coefficient because they're same degree. So it's a 1, not equal to 0. The nth term not equal to 0, so it diverges. Very good. Alright, so this one, I'm going to ask a student again. Okay, Matthew, could you please tell me if this one converge or diverge? 21.
That one would diverge.
Because?
Just if it went to infinity. Actually, no. Would it converge because then it would just converge to either 1 or negative 1?
No, yeah, actually, you did a good job on when you first look at this. It does not converge because it diverged actually. Because when you look at the cosine n pi, it goes to positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. You never know where it converged to. I don't know if it's positive 1 or negative 1. Does that make sense? Yeah, Joshua, Matthew. You go to positive 1, you go to negative 1, go to positive 1, negative 1. We don't know where it converges to. It can go here, it can go here, but we don't know which one. But it does not converge. Converge, we're talking about converge to 1 point, to one number, right? Okay, so it diverges. Alright. The next one, 1 over n cosine n pi. Does this one converge or diverge? I'm going to ask a student here. Lacey, could you please tell me if this one converge or diverge? Lacey?
I think it diverges.
You think it diverges? Okay. So does anyone else have a different opinion? Diverge or converge?
Is it pretty much just an alternating series of 1 over n?
Okay. Very good. Okay. I don't say who said that because I'm writing here. But it's a very good answer. It's an alternating series. Thank you very much. Perfect. It's an alternating series. Because cosine pi is negative 1, cosine 2 pi is 1, cosine 3 pi is negative 1, cosine 4 pi is 1, so it's negative 1, positive 1, negative 1, positive 1, it alternates from negative to positive 1. So now, if its odd number is negative, its even number is positive, and it's alternating series. Now, if it's alternating series of negative n, negative 1 to the power n, 1 over n, this one will converge, okay? Because you compare those two. You can compare n goes to infinity, n goes to 0, an plus 1 is less than an, so it converges. Very good. Okay, so next one, converges. You have three options actually right now. I'm gonna ask a student here again. Travis, could you please tell me if this one converges absolutely, conditionally?
This one would converge absolutely.
Converge
You
absolutely.
take that
Yeah.
you take the absolute value, get 1 over 2 to the n, and r is 1/2.
That's perfect. Okay. All right. So that converges absolutely. Very good. Thank you very much. Next one, I'm going to call student here. Luke, could you please tell me if this one converge or diverge?
That one should converge absolutely.
Converge absolutely. Why does it converge absolutely?
Because the absolute value would just be 1 over n factorial, which converges.
That's very good. 1 over n factorial converges. Okay. Thank you very much, Luke. And then next one is alternating series. Okay. So I'm going to call another student here. Nicholas, could you please tell me if this one converges or diverges, or which one?
Does it converge conditionally?
Converge conditionally. Very good. Why does it converge conditionally?
Is it because it's an alternating series? Because if you take the absolute value,
This one converge. Perfect. This one converge because alternating series. You can check two things: an equals 0 and an plus 1 less than an, and the alternating series. Okay, so this one converge. However, if I add absolute value 1 over n plus 5, this one will diverge because I can compare this 1 over n and it's p series. These two have exactly the same converge or diverge. You compare these two, get 1, which is finite number. This one diverge because p series, p equals 1. Okay, so it's diverge, and so it converges conditionally. Very good. Thank you very much, Nicholas. Next one, Jasper, could you please tell me if this one converges or diverges?
This one diverges.
Because
If you take the absolute value, you get the limit as n approaches infinity is not 0.
okay, the nth term test equals 6 is not equals 0. So nth term not equals 0, it diverges. Perfect. So 27. Joshua, could you please tell me 27?
It converges absolutely.
Converges absolutely. Why does? Okay.
If you take the absolute value, you get 1 over n to the 5, which then converges.
Okay, because the p squared p equals 5. That's perfect. 28. Zijian, could you please tell me? P larger than 1, it converge. Okay, so you think that square root of p will not converge? So how about this one? n from 0 to 1, -1 to power n, and then 1 over square root of p. So it's square root of n. Does this one converge? P bigger than 1, for sure, we know that. P bigger than 1, it converge, for sure. If P bigger than 1 is P series, it converge for sure. How about this one? Now this one is P equals half, right? Does this one converge? Can anyone else tell me if this one converge or diverge? It's alternating series. A n goes to 0, a n equals 0. That's true. Compare 1 over n plus 1 and 1 over n, 1 over square root of n. This is bigger, this is smaller, so the whole thing will be smaller. And an plus 1 is less than an, so this one converge. Alternating series is converge. So this one converge at p bigger than 0. If it's less than 0, how about less than 0? Less than 0, no, not good. Because if you do less than 0, for example, n to negative 1 to 1, so this one will give you negative power n, just n. This is that absolutely will convert, will diverge, because nth term will not equal 0 anymore. So p bigger than 0. Make sense? 时间? Okay. So 29. Okay. P not n not equals negative p. Okay. Because as long as this is not equal 0, then it will converge. 30, how many one we have? We have 2 more. Okay, we can do real quick. So number 30. Thea, could you please tell me this one? First, we know this one converge, right? P series. Converge by what? By geometric or by this? Limit convergence. Very good. 32. Okay, so I'm going to call student here. Lacey, could you please tell me if this one diverge or converge here?
It diverges by direct comparison test.
Diverge by direct comparison test. Very good. Okay, because you can compare this 1 over n. Thank you very much. You now this is for today's class.